Queria dar boas-vindas a todos vocês aqui no nosso evento. Na verdade, quando eu digo nosso, é o nosso porque é um evento coletivo, né? É um evento que foi organizado pelo Instituto Pereira Passos, pela Secretaria de Educação e pelo Consulado americano. Então, eu tenho mais que agradecer aos parceiros que trouxeram esse evento aqui ao Planetário. Nós estamos aqui na cúpula Carl Sagan, que é a maior cúpula do Brasil, recebendo vocês aqui de braços abertos. Eu espero que vocês tenham uma boa interação com a palestrante. Eu espero que vocês aprendam muito e ensinem também, porque a vida é uma troca. Então, sem atrasar muito o evento, eu queria chamar o Felipe Mandarino, do Instituto Pereira Passos, que organizou isso aqui tudo com a gente, para fazer, às vezes, de mestre de cerimônias. Felipe, é com você.
Obrigado, Sherman. Deixar claro, eu organizei aí com total apoio do Planetário, do Consulado americano, da Secretaria Municipal de Educação e diversos outros parceiros. A MultiRio está aqui também gravando uma matéria, então vai ser um prazer ter vocês aqui e ter a Dalia, claro, a NASA aqui podendo compartilhar o trabalho que eles fazem, tá? Vocês vão ouvir muito a Dalia falar sobre o trabalho que a gente faz aqui no Rio, nessa parceria com a NASA, então eu não vou dar spoiler. Queria apresentar a vocês a subsecretária de Ensino da Secretaria Municipal de Educação, Rejane Faria. Está aqui, um grande prazer ter você com a gente, Rejane. Então, os alunos são seus, fiquem à vontade aí para recebê-los e obrigado de novo pela parceria.
Obrigada, Felipe. Obrigada. Bom, boa tarde, meninos, meninas, boa tarde, nossos colegas professores, funcionários que trouxeram os alunos do Grêmio, boa tarde, pessoal da MultiRio, e boa tarde, os alunos do IB, os colegas professores, sejam muitíssimos bem-vindos. Em especial, eu quero saudar a Dalia e o Consulado americano pelo carinho, por trazer para o nosso conhecimento o que a gente vai aprender e identificar no nosso território do Rio de Janeiro. A gente vem vivendo modificações que nós, enquanto cariocas, estamos percebendo isso no nosso cotidiano, mudanças constantes que a gente não consegue compreender, ventos para além de alguns limites que a gente conhecia, outras tantas coisas. Eu não sei muito das ciências e das geografias, eu sou da área das exatas, da humana, de letras, mas é sempre muito, muito, muito importante aprender. E aprender no espaço que eu, por exemplo, que fui aluna da rede, como vocês, o Planetário é um espaço afetivo na nossa memória. Eu estava falando com a Dalia que todos nós, alunos da rede, passamos por esse espaço aqui. E é um espaço de magia. A gente já chega, parece que o mundo todo está aqui com a gente, né? Então, que esse momento que a gente vai viver hoje aqui, de forma coletiva, seja um momento de enriquecimento, não só do conhecimento, mas das nossas práticas diárias, nos entendendo enquanto parte desse mundo que precisa de uma atuação cidadã e respeitosa. Então, que tudo que a gente aprenda aqui, que a gente traga para a nossa vida, né? Que a gente traga para a nossa prática de ser humano e de cidadão. Tá? O nosso carinho, Dalia, desde já, o nosso carinho ao Consulado americano, pelo afeto que já proporcionou aos nossos alunos, e a prefeitura, que tem um centro, o COR como centro de referência, que vem mudando. Eu, como cidadão, tenho o aplicativo, ele já faz parte da minha vida, eu aviso a minha família toda, não vai por ali, vai por aqui, ali não pode. Então, que passe também isso tudo a fazer parte do nosso cotidiano, para melhorar a vida do cidadão e fazer de nós cidadãos melhores e mais felizes, né? Felizes mesmo, tá bom? Um beijo para todos. Boa tarde, meninos e meninas.
Obrigado, Rejane. Gente, eu vou passar a palavra para o Kevin Brosnahan. Tá ótimo, Kevin. Tentando gastar o meu inglês aqui um pouquinho. É ex-aluno do IBEU também, gente. Prazer ter vocês aqui. vai apresentar a Dalia, vai receber vocês. Agradeço de novo ao Consulado, a todos os parceiros que nos trouxeram essa oportunidade de estar aqui hoje. Kevin, fica à vontade, eu vou lá para cima, ficar na logística, qualquer coisa, estou na área.
Obrigado. Boa tarde. Boa tarde. Meu nome é Kevin Brosnahan, do Consulado dos Estados Unidos aqui no Rio de Janeiro. Agradeço a presença de todos e vejo nossos parceiros, a NASA, Secretaria Municipal de Educação, o IPP e a Fundação Planetário também, e nosso amigo Sherman. Obrigado. Obviamente, nos encontramos no local certo para falar sobre espaço, exploração, inovação e o poder de usar tecnologia para superar barreiras antes consideradas inimagináveis. Esse ano estamos comemorando a chegada da humanidade na Lua pela primeira vez. Há 50 anos, Apollo 11 pousou na Lua com 2 astronautas. Mas eles trouxeram todos os pensamentos do mundo. O evento capturou a imaginação do mundo inteiro e estabeleceu os Estados Unidos como um líder em tecnologia, ciências e exploração espacial. No dia 20 de julho deste ano, inauguramos uma exibição aqui no Planetário que explica toda a história da primeira chegada de homem na Lua. O espaço continua capturando a imaginação de todo o mundo. Até sexta-feira, quando tivemos a primeira caminhada no espaço só com mulheres. Hoje em dia, a NASA continua explorando o universo e também nosso mundo. Os avanços de tecnologia espacial da NASA nos ajudam a entender melhor nosso planeta e a NASA está aqui, compartilhando sua experiência com o Brasil e a cidade do Rio. Temos o prazer de ter a doutora Dalia Kirschbaum aqui conosco hoje. Ela se formou na Universidade de Princeton, nos Estados Unidos, continuou para mestrado e doutorado na Universidade de Colômbia, em Nova York. Atualmente, ela é cientista pesquisadora no Goddard Space Flight Center da NASA. Seu foco é em avaliação de risco de deslizamentos usando tecnologia de satélites e de sensores remotos. Por favor, coloquem seus fones e vamos dar as boas-vindas à doutora Dalia Kirschbaum.
Well, thank you so very much for having us. It is so exciting to look up and see all of you coming to learn about science. Okay. So first of all, I have to ask you a question. Who likes science? It's not, if you don't, that's cool. All right, good. All right, I like that. All right, by the end of this talk, hopefully, all of you will be raising their hands because there's so many different things about science and technology and space that hopefully will excite you even if you don't like the moon or even if you don't like Mars, though I don't know how you don't like those things. The whole point of this is to talk about how we can use science to understand our universe, but also how we can understand our city. So I'm here this week, I just flew in on a red eye, and I'm here to talk with the city and work with the city about how we can look at rainfall-triggered landslides, which we'll talk about, and heavy rainfall and flooding. Have you ever experienced flooding in your area? Raise your hand if you've ever had a flood. Yeah? All right. How about a landslide when the rock and soil came down? Has anyone seen one of those? Okay. Well, around the city, there's a lot of them. In fact, around the world, there's a lot of them. And so I'm going to talk a little bit today about how we're learning about that, but we'll start with the very big picture because NASA studies the universe, it studies planets, and it also studies our planet. All right, so if we go to the next slide. Ooh. This is exciting. All right. Now we're ready. Okay, so I wanted to give you a little bit of information about me. I liked science when I was little. That's me at the Kennedy Space Center in Florida when I was about 8 years old. I didn't have dreams of being an astronaut then. but I now know some astronauts, so that's progress. And then I did my schooling, as Kevin said, and I studied geosciences. So I really liked math, and I really liked science, but I wanted to understand what we can do with it. And so the thing that really captivated me was natural disasters. I liked chaos. I liked things that happened really fast and things that affected a lot of people. And so my research focuses on how we can understand that and how we can hopefully improve it. So we can keep going. And I do a lot of things in my job. One of the things that I do is I work with satellites, and we build satellites at NASA. We build satellites to look out at the universe, to discover water on Mars, to look at the moons of Jupiter. But we also have satellites with their eyes pointed down at Earth. And so the satellite that you see behind me, that's me, we call it a bunny suit, is the satellite called the Global Precipitation Measurement Mission, GPM. And I was standing in front of it. It's the size of a small school bus, and I have never been unable to speak as when I was in that room. I was standing next to something that was going to go into space. And that was really cool, because it took 15 years of science planning, of engineering planning, and I was there when it launched into outer space. And that actually, over there on the left, is me doing media coverage of that event when it launched. And I'll show you a little bit more about that. So one more slide about me, and if we just keep clicking all the way through. As I said, my study area is landslides, but I also work with the disasters program at NASA. And the goal of the disasters program is to really understand what and how we can bring satellite data to help during disaster settings around the world. What groups, what people can we do? And so if you click, this is just a video of me just last week talking about how we can bring rainfall into everyday life. And I was talking to media channels across the country to connect what we do at NASA to people sitting on their couches at home watching TV. All right, next slide. So what do we do at NASA, right? Everyone thinks about NASA, we think about space, think about the moon landing. So we look at astrophysics, we look at how stars are born. That's on the left is from Hubble. We look at the sun, we look at how the sun can affect us on Earth and solar winds. We look at other planets, and we also look at our planet. We look at the Earth. And so the way we look at the Earth is through lots and lots of different measurements, and we can also look at how those measurements affect us, how it affects our ecology, how it affects our air quality, how it affects our water resources. So if you go to the next slide, this is some of the satellites that are orbiting Earth right now. And all of the satellites that you see here are taking data as they orbit Earth every single minute of every single day and sending that data back down to Earth so that scientists can analyze it. But you know what the cool thing about this data is? It's free. It's open, and anyone can look at it. And in fact, I know people in this room, teachers here, people in the city, have looked at this data to help understand what's happening in Rio. And that's what we're talking about this week, and that's what we've been doing for the last 5 years together. So we take this data and we translate it into an understanding of how the world works. And so what we say with this is that it's a system of systems. We can't just look at how much it's raining. If you think about Rio, right? If it's raining outside, if it's heavy rain, if it's light rain, well, we need to know, is it already wet? You know, where are the winds blowing to know whether or not it's going to cause a landslide or a flood? And we can also look at where the clouds are, and we can look at how warm the water is, because we know that if there's certain bacteria in the water, it can cause problems in our local water here in Rio. If there's natural or human-caused pollution in the water. And so with all of these different elements, we can start to understand how our Earth system is behaving. And NASA can do this at a global scale, but we can do it locally here in Rio too. So if we go to the next slide. All right, so let's talk about the satellite that I work with because it's cool. And so this is a satellite you just saw in that clean room that I was in, but it works with other satellites around the world. All of them are designed to measure rain and snow. And if you put them all together, it forms this global, seamless picture of rain and snow. But it's not just the US that's doing this. This satellite was built by NASA in the United States and the Japanese. And it also includes data from the European Union, from Europe, from France, from India. And we have tested this data in different places in Brazil. We work with Brazil all the time. And so to get this picture, you can go to the next slide, to get this global picture of rainfall takes a lot of international cooperation. Speaking of that, this is how the satellite can get built. This is the timeline showing how the engineers at NASA and in Japan and around the world work together to build these satellites. So we call this one GPM in a minute. You can see them installing the different parts of the satellite. You can see them doing all the testing. They're deploying the solar arrays, the arms that give the satellite power. And then in just a few minutes, it's going to be flown to Japan, where it's put on a boat, tested again, and then it's put into a rocket. And then it launches. So that was a pretty quick time series of watching this, but it took 15 years to build. And so the things that we're talking about now, the science ideas and the engineering ideas we're talking about now, you guys are going to be the ones to build them. You guys are going to be the ones to do the science. So if you keep going, there's some really cool things that we can learn about looking at rainfall. In fact, one of the things this satellite can do is it can look three-dimensionally. It can look inside the hurricane. So let's zoom into one. This was a hurricane called Hurricane Dorian. It had a big impact on the Bahamas this past season. And it was a really, really big hurricane. And so what you're seeing here is we're actually going to fly inside the hurricane. We're going to see the structure of the rainfall all the way from the surface through the eye of the storm to the top of the atmosphere. And by being able to see all of that detail, it helps weather forecasters around the world improve the estimates of rain and where hurricanes may impact people. And you can go to the next one. So we can look individually at each storm, but we can also look globally and see where storm systems are coming. So this is an example of the last, mostly, 7 days of rainfall. And you can see, you can look at where Brazil is, you look at where Rio is, and you can start to see all of this. See that flickering in the Amazon every day? Well, that's called convection. The earth heats up, the land heats up, and it causes rain to form in the Amazon that then moves across and rains out every day. And with a satellite like this, with information, we can really start to understand these patterns. But the thing that I do is we can also start to see how rain impacts things on the ground. So what I study are those things, landslides. And Rio has them. And we're working together following the leadership of Geo Rio and IPP and other groups and Alerta Rio to better understand these. And so what we know is that, if you want to just play it again, Felipe, we know that let's see if it works. We know that as it rains, the soil gets saturated, right? We have more water in the soil. And when the water gets too much, it can actually cause water to build up underneath, and then the whole mass of rock and earth can come down. And it affects roads, it can affect the rivers and houses. But we know that with different satellite data, we can better understand these processes. And working with Rio, we can look at that at a very local level. So where are they around the world? So this is work that we've been doing to better understand the distribution of where landslides are happening around the world. And the size and the color of the dot indicates the number of fatalities, the number of deaths that have occurred. And so you can start to understand that there's some areas where there's a lot of fatalities or deaths from landslides, and some areas where there's less. And if you go forward. So what we've done is we've started to look over time, and we've looked at how the likelihood of landslides may change over the year by season. And so you can see that we're going through the seasons here, and when we start to get to the wet season, the rainy season in Rio, in November, December, you'll start to see it get red in the city of Rio. And so what we've been doing is we've been taking this type of information, bringing together observations to get a better understanding of how we can improve prediction of these types of events in Rio and also around the world. So if you go forward. So the other reason that I'm here, in addition to talking about really cool science, is that in 2015, NASA and the city of Rio and the mayor's office and all of its entities, we entered into an agreement, a partnership. As far as I know, this is the only type of partnership of its kind. The only time that NASA is directly partnering with a city to use Earth observations, use local data to better understand what's happening at the city scale. So this is a really unique opportunity for all of us, and we're really excited about it. And so if we can click through, and the goal is to really, as I said, connect on many of these different levels. And so if you keep going, we'll just click through. As I said, we're looking at landslides, we're looking at climate change impacts, we're looking at water and air quality, as well as education and reaching out. And we have some teachers here today we've been working with for a while, and it's been very exciting. And we've been expanding these collaborations. So just this week, we're going to be talking more about landslides, but we're also going to be kicking off a brand new project to look at flooding and help model urban flooding to get a better understanding of how we can improve prediction of these types of impacts at the city scale. So one of the examples, has anyone ever heard a siren when it's raining? Have you guys ever been, it's raining a lot and there's a siren? Okay. Because I know that in some areas of the city, when it's raining a lot, sometimes there's a warning siren telling you to evacuate, telling you to be aware that there could be impacts. And that's all due to the groups at GeoRio and Alerta Rio and IPP and the City Operations Center, CORE, that make these sirens and sends out the alerts. And civil protection, of course. So what we've done is we've worked with the groups and we've tried to test the global models in Rio. And really, the city has done all the work in terms of really customizing that type of information to the local level. And so far, the results are promising, and we're excited to do a lot more work. All right, so let's keep going. We're also looking at how we can better understand these dynamics, this information, for citizens, for anyone out there. And so we've developed a new way to report landslides at the global scale. You can actually log on to this website and you can say, a landslide happened in my area, here's where it is. And so we're trying to grow the catalog by any one of you being able to report a landslide. And so we're working on merging that data so that anybody can be involved in gathering science information. So some other examples, and this is work by Felipe and his group, who's the master of ceremonies today, in looking at climate change and how sea level rise will affect the city of Rio. Because as the sea level rises, we know climate is changing, we know it's caused by human activities, And we know that the sea is expanding because it's getting warmer and because glaciers are melting, but more because it's getting warmer. And so the water's expanding. And so there are many portions of Rio that could be likely impacted by this. And so the group at the city and other researchers are working together to better understand those impacts. Another example is looking at how land cover has changed over time. So this is showing 2 different time slices. Before you were born, in the 1970s, and just recently in 2015. And you can start to see the changes at the city scale going back and forth, how much more concrete there is, how much more building. And by having all of those changes, that change in land cover, it affects where the water goes, right? What do you think? If you were to pour a bucket of water on a plot of grass and do the same thing with a plot of concrete, do you think it would act differently? Probably, yeah. So we need to understand how the land cover is changing to better model the impacts of where this water is going to go. The other thing that concrete and other cities do, not just in Rio, but around the world, is that the concrete, the blacktops, absorb heat, right? So if you were in the summer, right, you're getting into summer here, and you wear a white shirt or you wear a dark shirt, right? The sun is actually, you're going to absorb more heat if you're wearing a black shirt than the white shirt, which reflects some of that light, that energy and heat. And the same works in a city. If the sun is bringing energy into the city, and we see that the temperature is heating up, if it keeps getting absorbed, what is it going to make the city do? Get hotter, right? And so what we see is that we observe that. In fact, we observe pretty significant increases in temperature in the city because there's more blacktop, not just in Rio, around the world. It's called the urban heat island effect. And scientists in Rio and the universities are working on this. This is not our work. This is work using NASA data by scientists in Brazil to understand this. All right. So how does us understanding heat in the city affect the polar ice caps, right? Affect the glaciers and the movement of sea ice in the Arctic. So what you're seeing here is you're seeing data from NASA of the ice sheets in the North Pole. And so as this ice changes, you can see it moving and changing. It's starting to get less, isn't it? Starting to get darker. Well, what did we just learn about dark versus light in terms of absorbing heat, right? If there's less ice to reflect all of this energy back out into the solar system, it's going to start trapping more heat, which means it's going to start warming up faster. And that's why it's so important that we keep the ice sheets and we keep sea ice in the North Pole. All right, so let's keep going. Another thing we can look at is how sea surface temperature and currents are changing. This is actually quite a cool visual, but because there's so much detail, you can't really see. But what you see is these paths of warm water that are moving heat all around the Earth. And we can both observe it and we can model it. But my all-time favorite graphic is next, which is we can take the smoke, sea salt, and dust and look at how all of these different elements interact to better understand our Earth system. So unfortunately, we can't see South America here. Sorry about that. It's a global model. But what we can see is we can see dust and smoke coming off of the western United States because it's burning. There's a lot of fires going on. Then you can start to see hurricanes that are forming and moving across the Atlantic that are being actually fed by the dust storms coming off of Africa. And so this was a particularly busy season in 2017, and you can start to see the lineup of all of these hurricanes that are being fed from the dust off the Sahara all the way through to the United States, and as they make landfall and go up. So we'll let this play for a few more minutes. And the point is that this is a model. This isn't actual data. But all of the data that from the satellites you saw is actually feeding what's happening in this model, helping to improve it. Hurricane Maria is a good example of a hurricane that made landfall and had devastating consequences across many different places. And we can start to understand the movement and evolution of these types of events. All right, so let's go forward. So what are we learning here? Why do we care? Why is this important? Why should you guys in Rio care about climate change? Care about how satellites study the Earth, right? It's so far away, it's big. But you know that in the summer, when it gets really, really hot, that it's going to get hotter. And it's going to get hotter in Rio, because we know that because the temperatures are rising. And it doesn't rise everywhere the same. But we know that it's going to get hotter because cities get hotter. And we know that we can see these differences in changing temperatures. And so what you're seeing here is moving through the years, every 5 years, how temperatures have risen in different areas. So you see that in some areas it's not getting so much warmer, but in areas like the Northern Hemisphere, it's starting to get warm, and then you see what's happening once we get to current conditions. All right, so to bring it back to home, okay, so yeah, so this is true data. This is not a model. So if we go to the next slide, this is the last slide. And I just want to say that, you can see what Rio looks like from the International Space Station. We have people in the International Space Station that live there. And as we heard in the introduction, we had the first all-female spacewalk on Friday, which is a really, really, really big deal for a lot of reasons. Yes, we're very excited about that. And you know what? Do you know that it didn't happen in March? Does anyone know why it didn't happen in March? Yeah, it's because they didn't have enough women-sized spacesuits. But now we do. And so we'll never have that problem again. And do you know who was controlling the spacewalk from Mission Control in Houston? Another woman. So the possibilities are endless. We have people up there right now looking down at Earth and helping us understand the big picture. But we're here today, we're in Rio, and the teams in Rio and the scientists and the students every day are working to better understand not just what's happening in Rio, but understand what's happening in the much bigger area. And so it's such a pleasure to talk to you. I hope that I've inspired you, or at least made you a little bit excited about science, because there's so much that you can do. There's so much that you can apply with what you're learning now. And once you do your math and you do your science, which may not be the most exciting right now, but it will be exciting later, because you can do really cool things like launch rockets. You can do really cool things like be an astronaut or study space and how the galaxies form. But you got to get your math and science degrees before you do that. So listen to your teachers. And never stop exploring, because there's so much that we can learn. So thank you so much, and we'd love to take questions, both the Rio team and myself. So thank you guys so much. All right, thank you. So I think that we have time for questions. And I will turn on my little thing. So does anybody have questions?
Alguém tem uma pergunta? Pode falar em português.
Yeah, Português.
Eu posso falar em português. O que vocês preferem?
Só tem que usar o microfone.
Great.
I studied biology and sciences at university in the United States years ago. So a lot has happened since then. Eu estudei na universidade nos Estados Unidos, as ciências, muitos anos atrás. Então, eu tenho algumas perguntas, porque as coisas mudam, né? A ciência está sempre evoluindo. Science is always evolving. Can you talk to the students a little bit about the Intercontinental Convergence Zone and its importance in Brazil, and how it affects droughts and flooding and things like that, and perhaps a little bit about climate change and how it exacerbates the norms? And
Yeah, Absolutely.
Because I think there isn't a whole lot of understanding there. I think, Brazil is touted as the terrestrial lungs of the earth and its importance. And I don't know how much students study about that in the schools here. Eu estou falando sobre uma correnteza da atmosfera que é muito importante, que controla as chuvas e as secas aqui no Brasil e na América do Sul. Eu sou americana, então desculpa se eu cometer algum erro em português. Eu não sei muito falar sobre essas coisas em português.
Yeah, thank you so much for that question. So what you were talking about, the intertropical convergence zone. So the Earth is a sphere, we know that, right? And what causes seasons? All right, we need, so basically, I'm going to get to my point here, I promise, right? So we have our Earth right here, but the Earth isn't straight up, right? It's tilted. And so the reason we have seasons is because this is the sun, the Earth is going like that around the sun, right? So in the winter, in the northern hemisphere, it's summer in the southern hemisphere, and the heat is stronger as we go to the southern hemisphere, and then the north, it's pointed towards the sun, so it's warmer, okay? That's why we have seasons. But that also is why we have this really, really warm band of water, because the sun is always heating it in that region, and that's why it moves north and south every year. So what happens is it's really warm, and it starts to evaporate, water starts to evaporate, and then it forms really, really strong thunderstorms. And those thunderstorms in the tropics, where you guys are, move up and down. It's really, really important. Because, for example, in Africa, we can actually see as the sun heats the water, heats the land, and causes more thunderstorms, it actually causes the farmers to know when to plant their crops. And if it doesn't progress, if the intertropical convergence of this band of really strong thunderstorm doesn't move up and down, then actually they could have a drought, they could have a famine in parts of Africa. They could have big problems. And the same is true in South America, right? So that type of really, really warm water that's causing this movement is really important for agriculture around the world. It's also important for understanding where diseases might spread. It's important for looking at disasters. But for climate change, one of the concerns is how might extremes be affected, right? As we said, we know the climate is changing. We know that those changes are not the same everywhere. And in some areas, it's going to get wetter. And in some areas, it's going to get drier. And we know that, most likely, the wet areas will get wetter and the dry areas will get drier, which means that the areas that already have floods will probably have more floods. The areas that have more droughts will probably have more droughts in general. And so understanding these big picture changes of how those storm systems move, both in Rio and across that whole tropical region, is really important for better modeling those processes and how they change over time with things like El Nino. Have you guys heard about El Nino? Okay, we'll work on that. So those are really important to understand those big picture changes. Thank you so much for the question. I'd be happy to go on, but I'm afraid I'll bore people. Other questions? Yeah.
So many of us have grown up, and many of these kids still grow up hearing that jobs like the one you have, the work you do, is more suited for men, because men are naturally better at math and sciences. That's a biological thing. Well, that misconception still exists, still goes on. Do you feel that it has been changing? Do you think that there are fewer people who are still spreading that misconception? And what can we do so that these girls that are here listening to you are not contaminated by it, and so that they can pursue careers in technology and sciences, which of course they are able to do as the boys?
Yeah. So the misconception, let's be clear, the misconception is that men are better at math than women, which is obviously not true. We know that very, very well. And I think that the important thing is that, so let's take where I am, right? I'm at NASA, 30% of NASA's women, all right, 30%, but it's growing. And I mean, I don't mean to go back to the spacewalk, but it's kind of a big deal to know that we have female astronauts out there, right? We know that they are making a difference, and you know that they did it in faster time than they thought because they're more nimble, and they're better astronauts because their brains work better in space, and their vision isn't as impaired in space as men. So actually, women are kind of better at those kind of things, I'm just saying. But I think in terms of math and science, I think the challenge sometimes is seeing people to follow after, right? See people with a path that know you can get there. And okay, I'll be the first to admit that basic math and basic science, I really like basic math, so I shouldn't say that. I really, really like basic math, but it can be kind of boring, right? It's like, why are we doing this? How does it apply? But I'm telling you that it does. When you get to high school, when you get to university, hopefully, there's a lot of different ways it applies, and there's a lot of different perspectives. And so having men and women together tackling these problems only make it better. And speaking of, like, I'm at NASA, right? But we're also here, my colleague Sana's in the back. She's lived in like 4, I think, different countries before coming here. And Augusto actually went to the University of Rio, and he is at NASA with me too, and he is the one that's kicking off this flood project. So I know that I'm coming from Washington, D.C., and it seems kind of far away, which it is, it's really far. But I have colleagues from Brazil that are working with us at NASA. And so this international, we can only do science internationally. There isn't just one country that's leading. It has to be a team effort. And the only way that we can do this as a team is that everybody plays a part. And so I thank you for the question. I think it's really important that, you know, look at the astronauts and the mission control specialists and know that, you know, the times are changing. They're changing quickly. So I hope that we're all part of that.
Vamos a aceptar uma pergunta para deste lado. Quem tem?
Minha pergunta é a seguinte: as mulheres da NASA acreditam em vida inteligente fora da Terra?
You mean are there Martians on other planets?
Sim.
Probably. We just haven't found them yet. We know that there's water on other planets. We know that there's probably life on other planets, and we'll find it within the next, for sure within your lifetimes, but I'm guessing we'll find intelligent life within your lifetimes as well. But the only reason we can do that, to make another plug for Earth science, is because we have to use Earth as a laboratory to figure out how life can survive, right? And so it's called, we use Earth analogs. We look at Venus, we look at Mars, we look at the missions that have been launched to look at what we're calling the Goldilocks planets. The planets, you guys have heard the story of Goldilocks. She goes in and the bear, it eats the hot porridge too hot, cold porridge too cold, but the last porridge is just right, right? So we call those, I'm not kidding, we call them Goldilocks planets because they are the places that could have life. And we have missions right now, TESS is one of them, and I forgot what the acronym stands for, that is exactly looking for those. And the James Webb Space Telescope, which is going to launch in 2022, I believe, is going to look far beyond where Hubble does, to look at where the origins of the universe are, and then look at those planets to identify ones that could have life. So the answer is yes, we just haven't found it yet.
Outra pergunta neste lado aqui.
Bom, você trouxe informações de estudos de alta tecnologia. Eu gostaria que você fizesse uma ponte com eles, porque para os alunos pode parecer alguma coisa muito distante deles, no sentido de que essas informações e essas pesquisas e estudos estão muito além e que as coisas acontecem, os desastres naturais acontecem e nada é possível fazer no sentido do âmbito em que eles estão. Qual seria o papel, então, nosso como professores, os gestores e os da municipalidade, né, e individualmente deles como membros das suas comunidades, dos moradores dessa cidade, quer dizer, se apropriar dessas informações, sim, Mas como você articula, sendo uma estudiosa dessa área, como você articula isso no âmbito mais local, não só no sentido da população em si, mas dos administradores dessa cidade? Eu queria que você articulasse esse saber com a nossa ação de todo dia e a nossa responsabilidade em relação aos desastres, que são naturais, mas que também têm outras causas para além do fenômeno natural em si.
Thank you for that question. I'm going to answer the first part, but Inez, I'm going to look at you to answer the second part, okay? Is that okay? Okay. So for disasters, we've been working with the civil protection, we've been working with IPP, and I think, actually, it's probably better to talk at the local level for Felipe. I'm going to put you on the spot a little bit about how you've been working on it. But then I'm going to invite Inez to speak, because Inez has been working on mosquito habitats. What does that have to do with satellite data? Well, we can actually look at breeding grounds for where mosquitoes that may cause Zika, may cause malaria, and have students take measurements that help inform the global study of these illnesses. So I'm outsourcing. I'm going to send it to Philippe, and then Inez, if it's okay if you talk a little bit about the GLOBE protocols, because I think it's very relevant.
Thank you, Dalia. Gente, então, a sua pergunta, professora, é muito boa, porque, na verdade, hoje em dia, a cada vez mais forte é a corrente de tirar os termos naturais de quando a gente fala de desastres. O evento que causa o desastre é natural, é uma chuva forte, por exemplo, mas o desastre não é natural. O desastre tem a ver com um tipo de ocupação eventualmente irregular, ou então com algum outro tipo de problema ali que não é da natureza daquele espaço, daquele local. Então, isso é uma pergunta muito boa. Eu acho que, assim, o que as escolas, os professores, os alunos podem fazer, assim, a cidade tem muitos protocolos, a cidade tem um centro de operações, a cidade tem a defesa civil, a cidade tem uma pessoa da Secretaria Municipal de Educação que fica, 3 pessoas, na verdade, né, que ficam 24 horas por dia, 7 dias por semana no centro de operações, ajudando a ter todo um protocolo para desastres naturais, para violência, para crises. Então, tem muita coisa acontecendo. A Defesa Civil tem um programa Defesa Civil nas escolas, que visita as escolas, talvez alguns de vocês já tenham passado por isso, eu conheço esse programa. Então, assim, se empoderar de toda essa informação que está aí é importantíssimo, né? E o nosso papel aqui com a Dalia é tentar trazer ainda mais informação para que esses protocolos sejam ainda melhor informados e que tenham um efeito ainda mais importante na vida das pessoas e proteger a vida das pessoas, né? A gente sabe que deslizamentos de terra no Rio são um assunto muito sério, causam mortes, causam perdas de propriedade, uma série de questões. Então, essa parceria está aqui para trazer essa coisa que a gente viu global da NASA para a nossa escala local, para a realidade. Então, é até por isso que é tão único o que a gente está fazendo, como a Dalia falou, é a única parceria desse tipo com uma cidade. Então, é um aprendizado de mão dupla para a gente, para eles chegar nessa escala. Vocês viram ele ali trabalhando com o mundo inteiro, é um desafio chegar nessa escala, e para a gente é um desafio lidar com ciência tão avançada, mesmo a gente está trabalhando junto e conseguindo fazer isso. Eu adoro falar sobre isso, então eu vou parar por aqui, senão eu falo muito. Inês está por aí, Inês lá, Inês está lá, gente, professora da rede, fica à vontade.
Boa tarde a todos. A gente, na Escola Minas Gerais, aqui do Rio, a gente trabalha com a NASA desde 2015. A gente faz coleta de dados de atmosfera, de chuvas, aquele satélite que apareceu, o GPM, a gente coleta dados para ele, para o GPM, a gente coleta dados de temperatura, e o meu carro-chefe da minha escola é coleta de dados de mosquito. A gente tem armadilhas na escola e a gente coleta, pelas larvas, a gente identifica o tipo de mosquito, se é Aedes, se é Culex, e a gente faz a mitigação dos criadouros e espalha para toda a vizinhança. A gente vai à rua, a gente tem parceria com outros colégios, como aqui o Colégio Bilíngue do Estado. Então, a gente faz isso desde 2015. Então, é fácil, não é difícil.
Tem que ter boa vontade, todo mundo trabalhando junto, os alunos adoram, eu trabalho com 6º ao 9º ano, e dá muito certo. Quem quiser alguma parceria, é só entrar em contato.
Vamos lá, o Kevin está querendo mais perguntas, gente. Entre os alunos aí do IBEU e do município, quem vai se arriscar? Pode perguntar em português. Quem quer compartilhar uma experiência, fiquem à vontade.
Alguém? Não?
Mais uma pergunta. Você poderia falar um pouquinho sobre desflorestamento e desmatamento e como isso afeta a umidade na atmosfera e o ciclo de chuva e seca e como isso está criando um problema muito sério aqui no Brasil? Could you please speak a little bit about deforestation here in Brazil and how it's causing climate change to be amplified, particularly in the tropical zones of Brazil, where there's a lot of cattle farming and farming in general, a lot of agriculture, and how it kind of strips the humidity away from the atmosphere and disturbs the regular climatic cycles during the year.
I think you did a pretty good job describing that just now. Yeah, I mean, we know that trees are very important for so many reasons, right? Regulating the temperature, right? If you go into a forest versus sitting on a blacktop, where are you going to get hotter, right? Trees are going to be able to protect you. They also they bring in carbon dioxide, they send out oxygen. We need oxygen to breathe. They're important for that too. But this idea of changing and having changes in moisture actually does really, really affect the local climates. And so there's a lot of research in taking the data from satellites on changing land cover, which we can see down to like the size of this room. We can see this area and how different changes may impact the changes in vegetation, so plants and trees, but also how that might impact drought. And so if there isn't a source for, bringing in that moisture, the moisture is going to go elsewhere. It's going to go off into the ocean where there's a lot of water, right? And so it's really important that we have, trees planted in the cities to cool down our cities, that we keep, making sure to understand how that type of deforestation may impact not just kind of the local issues of moisture and, cooling the surface, but also it affects much broader areas because it changes weather patterns around the world because of those changes. And so I think it's a very important question, and it has both local and kind of far-reaching impacts. All right, students, please. I'll give you an extra NASA sticker. I will. I have a lot. Only for those that ask more questions. All right, there we go. Go
ahead. É possível ter carros voadores?
Can you have flying cars? What do you think? Yeah, I think so. You want to design one? Why not? So, we have, okay, so I have a watch that talks to my phone, and there's an app that tells me when to drink water. Is this useful? Probably not. But 10 years ago, somebody would have thought that and been like, that's absurd. A computer on your wrist is telling you when to drink. That's ridiculous, right? So a flying car may be ridiculous now, but in 20 years, we already have self-driving cars, so just pick them up, right? I think that's the beauty of technology. It's evolving so quickly that, yeah, why not? It's just going to take time to develop, and we need the engineering to do that. Yeah, totally. All right. I'm serious about the stickers. We should go find, we'll make sure you get one.
Eu não sei se a senhora ficou sabendo o desmatamento na Amazônia. Se a senhora ficou sabendo, o que a senhora acha sobre é muito importante o desmatamento.
Yeah, I mean, so I actually have a colleague who was here, Doug Morton. He was just on the national news like last week. Did you? I don't know if you saw him, but he was in the national news. Yeah.
Se alguém viu o jornal, vários jornais aqui no Brasil, cobrindo o desmatamento na Amazônia, vocês provavelmente viram um cientista da NASA falando português fluente, melhor que o meu, se bobear, é o Douglas Morton. E, inclusive, é colega da Dalia e um dos motivos pelos quais o Rio tem essa parceria com a NASA, né? A gente começou a conversar com ele ali, a facilidade da língua foi muito importante. Mas responde a pergunta, por favor.
That's right. Yeah. So, yes, it's important. I'll be careful here, but one of the things that the goals of NASA is to study, right? It's to observe, it's to model, it's to study. We don't make policy. We don't say, you should do this, you shouldn't do that. That's not our role. But what we hope is we can take the data and we can give it to those that know how to make the policy and make decisions about deforestation, about fires and burning, and can do that at the local level, working with the communities themselves to understand the impacts. But it's not our role to say what policies to implement. But the more data we have, the more information that we can really understand, it helps us to make more informed decisions about it. And that's what's happening right now. Yeah. It's a complicated issue on the policy side. On the science side, it's a little bit more clear-cut. But, you need both. Thank you for that question. All right.
I have a question.
Yeah.
Can you tell us a little bit about when was the first time you knew you wanted to study Earth from space?
Yeah.
And what inspired you, or did you meet a teacher or a scientist that inspired you?
Yes, I have 2 stories. I'll do quick.
Please.
Okay. So I was walking along the beach with my family when I was your age, and there was a thunderstorm in the distance, and I said, oh, I just learned in school that you count the number of seconds between when you see the lightning and when you hear the thunder, and based on that, then you know how far away the storm is. Has anyone heard about that? It's true. It's true. 5 seconds. Count to 5. That's 1 mile away. 1.6 kilometers-ish. And so, but at the time I didn't remember the conversion. And so my mom was like, well, that's great, but that's not really helpful information if you don't remember what the math is. And that's when I realized that math can actually be pretty powerful, right? Either we had to sprint to where we were staying to avoid this thunderstorm, or we had time. And so that was the first time I realized that math actually has real-world applications, and that was really exciting. And then, thank you. And then the second story, I actually was in college, and I had a professor. And I said, you know what? I really like math. I really like chaos. I really like natural disasters, but I don't know what to do with it. And he said, well, NASA studies the Earth. NASA has all of this information to study natural disasters. You could go do that. And I said, great. So I just had a teacher do that. But what ended up happening was that I'm the only one that's doing this at NASA. I'm the only one that's really studying landslides in this way at NASA. In fact, I'm only one that's kind of doing this in the world in this way. So that's pretty cool. And that was because some teacher suggested that this could be an interesting area of study. So listen to your teachers and seek out advice because they know a lot of stuff, generally. All right, good questions.
E aí, gente, temos mais algum tempo aí?
O sol apaga? O sol apaga? Um dia o sol vai apagar. Um dia o sol vai apagar?
That's not a funny question. That's a totally legitimate question. That's great. Like a couple hundred years ago, people had no idea. People thought the Earth was flat, right? And so we have satellites now that are looking at the sun every day. In fact, we have one that just went closer to the sun than anything has ever gotten to the sun before. They had to build special heat shields to protect it from the sun. But the reality is that the sun is a middle-aged star. So in our lifetimes, in our great-great-great-great-great-great-great-great-grandchildren's lifetimes, we're not going to see changes. We have a question up there. But we know that the sun changes its energy because it gets sunspots and it gets these big eruptions on the surface of the sun. And not only does that cause our weather and our climate to change a little bit, but it actually causes solar storms. So you think storms on Earth are cool? Solar storms are even cooler. Because what happens is all of this energy, all of this radiation is coming from the sun, and it actually can knock out our electrical outlet, our electrical grid. It can knock out our GPS. And so we have satellites and we have groups all over the world monitoring that, because if we have a solar storm that knocks out the power to Rio, would that be kind of a big deal? Yeah, for a lot of people. So the sun isn't constant. I mean, it rises and sets every day, or really, you know, we rotate. We orbit the Earth, or the Earth orbits every day, rotates. But yeah, the sun isn't constant. And so we look at that because we know that it impacts life on Earth. That was a great question. Yeah.
Bom, boa tarde. Eu tenho uma dúvida. É possível que daqui aos próximos anos a gente possa viver em outros planetas? Assim, a gente já tem esse estudo?
So right now, one of NASA's main focuses is to send the next man and the first woman back to the moon. And they want to do that by 2024. But the goal is to take that and then use it as a way to send people to Mars. So within your lifetimes, there will be people with one-way tickets to Mars. One way. But, so the answer is yes, it's in the plans. And they're working to develop the technology to keep people in space living for that long. They're doing tests, keeping women and men on the International Space Station for a year. One woman on the space station is up there for 9 months. It's the longest a woman has ever been on the space station, because they need to see if people can survive in space that long. With no gravity, your bones deteriorate, your muscles, well, not your bones, your muscles deteriorate, your vision's affected, you know, with no gravity. And so they're doing tests right now, but the goal with NASA is, we're calling it Moon to Mars. We're going to send people back to the moon, and then from there we're going to go to Mars. So, yes. I don't know beyond that right now, but Mars is the holy grail right now for NASA space exploration, human space exploration. And it has been for a while. Yeah. Oh, yeah.
Você poderia me dizer qual é o país ou estado assim do mundo que tem o maior número de deslizamento de terras? Já falei, já.
Yeah.
Já.
So the work that I do, we look at rainfall-triggered landslides, and areas like, you know, where you have really, really hilly mountains, where you have a lot of rain. Places like Indonesia and the Philippines, Nepal and India, and then places in South America, all, excuse me, along the Andes Mountains in Central and South America. We see lots of landslides each year. But you know what the interesting thing is that it doesn't affect people the same. If you saw my slide, it was pretty quick. In the United States, landslides don't kill many people. There's a lot of reasons for that. The roads are built differently, right? In some areas, the roads are not built they don't do the right mitigation. In some areas, populations are living in places that are really dangerous. And in the United States, too. So, but those are the areas that are the biggest, I would say. Indonesia, the Philippines, Central and South America, along the spine of the Andes Mountains. So, and we can look at all that from satellites, but we need local information to make sure that that's right.
Boa tarde. Eu queria saber se a base da NASA só está localizada nos Estados Unidos ou tem em outros lugares. Porque futuramente eu queria entrar na NASA para me ir para o espaço, porque eu acho muito legal esse lado assim da NASA.
Awesome. So the answer is there's space agencies all over the world. NASA is the US space agency, but there's a Brazilian space agency, Argentinian space agency. There's space agencies in Japan, in China, in Russia, all over the world. And you know what's really interesting? Is that everybody's working together, for the most part. And the only way to launch satellites and big satellites that we do is by cooperating and sharing information and resources. And we couldn't do that alone. No country can really do that alone. Because you need to cooperate and make sure that, one, your satellites don't hit each other. That would be bad, right? We need to make sure that we can share data, because if one satellite is launching with the same thing as another satellite, that's kind of a waste of money, right? And so there's these big organizing groups. I was just in Iceland 3 weeks ago, meeting with all the different space agencies about disasters, just for that purpose, so that we could work together on these topics and share our understanding and our data and the technology to a certain extent to improve that. So there's space agencies all over the world that you can be part of.
Olá, boa tarde. Na nossa rede, nós temos alguns professores muito interessados por tecnologia e aliado à ciência. Então, tem alguns aplicativos em celulares de realidade virtual aumentada, em 3D. Então, os alunos estão tendo algum contato sobre essa área científica através desses aplicativos. Aí você falou que os dados coletados pelas pesquisas são gratuitos, estão disponíveis. Aí eu queria saber, assim, porque se eles tiverem interesse de procurar, se tem como eles vão acessar esses dados e se tem realmente, assim, com essa realidade aumentada, que eu acho que para eles visualmente, né, é bem mais interessante.
Yeah. So we have, there are some projects that do virtual reality even for rainfall. You can go in and you can see the storm around you in 3D. We have ways to view it on a phone, right, to be able to look at a storm with essentially a 3D view. But one of the things that we've done is working with Inez and some of the other educators in Rio specifically, and working with the Planetarium team and others, is we've actually developed, or the teachers have developed materials to bring NASA data and resources into lesson plans in schools. Inez, do you want to talk about that? Or? Okay, so echoing what Inez already said, there are lesson plans for the teachers in Portuguese that teach the students how to work with NASA data. And once you start understanding how to access it, then you can look at anything you want. With virtual reality, there's also a group, and I don't remember where, but it exists, that they have virtual reality data sets that you can then look into. And so I'd be happy to follow up and try to find that for you, because we do have some groups that are looking at that to be able to understand it in 3 dimensions. Yeah, thank you.
Ok, essa vai ser a última pergunta.
Oi, eu queria saber se o homem foi realmente à Lua ou isso é tudo mentira.
O que você acha? What do you think?
Eu acho que é mentira, né?
Why?
Por causa que eu estava vendo no YouTube, a bandeira dos Estados Unidos, que estava presa na Lua, ela não se mexia. Ela estava se mexendo, só que a Lua, como dizem que é uma gravidade baixa, não tem uma gravidade, a bandeira ela ia ficar parada, não é? Por causa que no vídeo ela está se mexendo. Mas o certo seria ela ficar parada, porque não tem gravidade, ela não se mexe. Para andar já é um esforço, você precisa do traje para poder andar, correto? E eu acho que é mentira tudo isso. Essa é a minha pergunta.
Okay. So you saw one video?
Sim.
Yeah. Have you seen 2 videos? 3? 4?
Eu assisti a metade de um vídeo completo. Assisti o vídeo inteiro.
All right. So, part of being a scientist, part of being an explorer, is not taking the answer because that's the one in front of you, right? You can find anything you want on the internet. We all know that. And you probably have, and you shouldn't, but the point is that if you're going to be a scientist, if you're going to search for the truth, you got to do a systematic review, right? You got to look at all the websites. You have to look at NASA. You got to look at some other non-NASA sources. You got to look around. And then you can make a judgment for yourself about it, right? You can't just take one video and say, well, that's true. There's a lot of stuff that's not true, right? People think the earth is flat. Well, that's not true, right? And so you could find a very compelling video to see that too. And so I think that the important thing is that as budding scientists, you need to form your own opinions. But in order to do that, you have to consult multiple sources. So you know what I'm going to say, so I'm not. But I'm going to say, look at a few other YouTube videos. Look at some of the historical views. Read something about what it took to get there. Read why and how the astronauts 50 years ago were able to do this when they didn't have phones, they didn't have anything. In fact, walk around the exhibition outside. It's pretty amazing. And then you can form an opinion. But don't just form it on one YouTube video, or one half of one YouTube video. That's my suggestion. Scientist to scientist.
Obrigado, Dalia. Acho que vamos terminar aqui. Mas primeiro, todo mundo fiquem sentados, por favor, porque...
Fazer uma homenagem, um agradecimento. E a nossa aluna vai te presentear com um livrinho. Fala com ela.
Prazer, meu nome é Larissa. Eu vim te dar esse livro para você e agradecer muito pela sua vinda até aqui.
Thank you.